Let's build a portable air conditioner capable of cooling or heating a room in just a few minutes. A compact, efficient system that's very easy to make at home. Do not try to replicate what you will see in this video without the proper training or safety precautions. Manufacture of the condenser. With this copper tubing, we're going to make the condenser coil for our air conditioner. It's a 1/4-inch thick copper tube, 3 meters long. We'll make elongated coils using any spray paint can to shape the curves. Copper tubing is widely used in air conditioning because of its excellent thermal conductivity. We finish by bending the ends like this. The condenser is now complete. Evaporator manufacturing. Now we'll make the evaporator coil. To make this part, we'll also use 1/4-inch thick copper tubing, 1.5 meters long. Again, we'll use the same can, but this time we'll make a completely circular coil. Also, all the coils should be very close together, as you can see in the video. And to finish, we bend the ends like this. This is how this piece will look. Assembly. We're going to use this wooden base, which measures 45 by 28 centimeters. We've already drilled a series of holes to attach the different components. We'll use these brackets to attach the evaporator and condenser that we made earlier. We screw the brackets to the wood. We'll insert a nylon cable tie into each of the brackets. Now we're going to attach the condenser unit to the left side. We tighten the cable ties and cut off the excess. On the right side, we'll place the evaporator unit. Make sure to orient the ends correctly. We've taken the filter and capillary tube from a broken domestic refrigerator. This is the filter that will trap any particles or impurities from the refrigeration circuit. This is the capillary tube. It's a very thin tube, approximately 0.6 millimeters in inner diameter. We're going to uncoil 50 centimeters of this tube. We'll insert the filter inlet here. And we'll try to make a small spiral that will be placed around the evaporator tube inlet. We take the approximate measurement where we need to make the new spiral. And now we will use a small cylinder to shape the spirals. Five or 6 turns will be enough. We remove the cylinder and now place it in its position. We unwind 2 turns from the end of the capillary tube and insert the end into the evaporator inlet. With pliers, we carefully crimp the evaporator inlet, being very careful not to crush the capillary tube as well. Now we will apply flux to the areas where we need to solder. We will put a little on the junction of the condenser and the filter, and we will solder it with a soldering iron and solder. We will also apply flux to the junction of the capillary tube and the evaporator, and again we will solder it with solder. With fine sandpaper, we will polish the surface so that it looks new. This is how our tubes look soldered. Now we will attach two fans. These fans operate on a 12-volt DC motor and have a diameter of 80 millimeters. The airflow will circulate in the direction of the arrow. Therefore, we will position one facing the condenser and the other facing the evaporator, directing the airflow towards them. This is a 9-volt battery holder. It has a built-in power switch. We'll secure it with 2 screws here. We'll also attach this small terminal block. Here we have this 12-volt water pump. So this is the suction port where the refrigerant will enter, and this is the pressure port where the refrigerant will be expelled. We need to connect all the black wires together. We'll connect the black wires from both fans and the pump to the negative terminal of the battery. We'll attach an electrical terminal to the wire connection. Now we'll also connect all the red wires. The red wires from the fans and the pump will be connected to the positive terminal of the battery. We'll attach another electrical terminal, and we'll secure both terminals to the terminal block. Remember to subscribe if you like this type of content and leave a comment to support us. This piece will be the refrigerant pump bracket. We insert it and tighten the clamp with these screws. We'll fix it to the wood in this position. The pressure port connects to the condenser. We'll use a clear PVC tube and secure it with metal clamps. The suction port connects to the evaporator. Again, we'll connect it with another PVC tube and 2 metal clamps. A simple 9-volt battery will provide enough power to run the entire system. We insert it into the battery compartment and turn on the switch to verify that everything is connected correctly. Now we're going to test the pump. Air should be coming out of this tube. Correct, it's working as expected. We won't test the suction because we don't want any moisture inside the pump. This could be fatal for our refrigeration circuit. This acrylic plate will separate the cold zone from the hot zone. We previously drilled a hole to pass the pressure tube through, and now we can connect it to the condenser. Once assembled, we'll attach the separator to the wooden base. Now we'll also connect the suction tube to the evaporator. But we won't insert it completely yet. This will be our refrigerant gas. It's isobutane. We'll inject it into the system using a hypodermic needle. We attach the needle to the outlet of the gas canister. We pierce the needle into the PVC tube and inject the gas into the system. Isobutane, also known as R600A, is an excellent refrigerant. We won't fill the system completely. A little gas should be enough. We quickly insert the tube to seal the leak and secure it with its clamp. With this, our portable air conditioner, which generates both cooling and heating, is ready to operate. Let's turn it on. And now the tests begin. Air conditioning equipment test. When the switch is flipped, the fans and the pump start simultaneously. The pump compresses the gas and circulates it through the condenser. The filter collects impurities, and the capillary tube, being very thin, causes a large pressure increase in the condenser. Upon reaching the evaporator, the tube's cross-section increases, resulting in a significant pressure drop, and the gas evaporates, absorbing heat. This is why it cools down. In just a few seconds, we can see ice or frost starting to form around the evaporator. We've sped up this shot so you can better see the freezing effect. Conversely, the condenser coil emits heat, which could be used to heat a room. It cools at one end and heats at the other. Using a laser infrared thermometer, we can verify that the temperature has dropped to 10 degrees below zero. And in the condenser, the temperature has risen to 30 degrees Celsius. The fan will provide a pleasant stream of cold air, capable of conditioning a room of up to 30 cubic meters. You can see that the ice we scrape melts in our fingers. It's real ice, contrary to what some comments about the previous prototype said. Let's cool this can of Pepsi. Unfortunately, Pepsi hasn't promoted this video. We've sped up this shot by 500%. In just a few seconds, the soda can has frozen completely. When we turn off the switch, the ice automatically begins to melt. Air conditioning for a room. The design of this portable air conditioner prototype allows us to install it in a sliding window with a blind. Here we can see how it fits perfectly with the window tracks. We'll lower the blind to prevent hot air from entering from outside. Now, by flipping the switch, it will begin to cool the air inside our room. We'll speed up the recording a bit to better appreciate the cooling effect. We have cold air inside and hot air being expelled outside. Since we've had it on for a longer period, the temperature reading drops much lower, reaching 19 degrees below zero. The device works. This is pure science. Our portable air conditioner works as expected. Thanks for watching the video to the end. Let us know if you've built your own and how you've used it to improve your life. See you in the next video.